Hello and welcome back to Introductory Electromancy. Today we are discussing diode bridges. In the last episode, we talked about power transformers. A power transformer is basically just two coils of wire which are wrapped around the same magnetic core. I used the example of an old linear design power supply which directly converts the AC power from the input to a lower frequency AC, rectifies it with this diode bridge, and then filters the resulting pulsing DC using this electrolytic capacitor to produce a smoothed output voltage. I contrasted it with the more modern switching power supply, which is capable of producing more output current at a significantly higher efficiency. It is also lighter weight. This is accomplished by first rectifying the power input, then taking the high voltage DC that is produced by doing this, switching it very rapidly, which enables you to use a smaller and lighter transformer as a result of the higher frequency. That smaller and lighter transformer is what allows for the weight savings. You can see the transformer is the majority of the physical size and the weight of this older style linear power supply. If for some reason you find yourself wishing to learn more about switching power supplies, the book that I used is called Switching Power Supplies from A to Z by Sanjaya Maniktala, whose name I am no doubt horribly mispronouncing. But I do not think I'm going to link it at the bottom of these videos because it is not as directly connected to an introduction. I might do it anyway. You know, I might as well. I am basically building a library of books I'm telling you to read. So what's one more? Isn't that right, Ladybug? Now let's get practical. We're going to look at the operation of a diode bridge, which we have already drawn here and discussed in the last episode, but we are going to make one in real life, in living Technicolor. So, this is an LED and a resistor. The resistor prevents it from blowing up. Very exciting, I know. Now, if we connect our battery, the light should light. Lo and behold, it does. And it turns off when we disconnect our battery. Now, if we reverse the terminals, because it is a diode, a light-emitting diode, it only conducts in one direction. The light does not light. Very tragic. I know, you are crushed, simply crushed to see this, Ladybug and dear viewers. So, we will be constructing a diode bridge. That is, this circuit here, these four diodes in this particular configuration, function to make it so that their output is always positive at the cost of two diode forward voltage drops. So you lose 1.4 volts doing this. Now, my stack of components has only grown since we have last spoken. In reality, I pulled down other boxes from the attic. So these are 1N4004 diodes. Very exciting, very happy, fun time. Yes. Much wiring. we will need 4 of them. This diode bridge circuit is very common. If you disassemble older, heavier linear power supplies, you will very frequently see 4 diodes in them. However, you can also purchase diode bridges as a pre-assembled module, which have all 4 diodes built in. Their terminals will be labeled plus, minus, and squiggle for the AC input. And here we can see on the far left plus, on the far right minus, in the middle a squiggly line indicating where the AC power is input. Isn't that right, Ladybug? Ha. So, now we take our 4 diodes, carefully shoo the ladybug off of them. It says carefully shoo. Boy, you really like those diodes, huh, Ladybug? Wonder why that is. What do I know? I see. I have catapulted my diodes off into the abyss. Well, that's where it shall live for now. Alright, you are not going back in the parts box. It's not a good place for you. We'll move you to a plant once I'm done recording this. It's January. If I put you outside, you would freeze to death. No, not in the parts box. Bad Ladybug, no. Anyway. So I'm going to make a happy, joyful, and glorious diode bridge. Which is pretty easy to do. Going to directly connect it to this LED. And these power rails. All right. So now, assuming I have not made a grave error, regardless of which way this input power is connected, the LED will conduct. Is because of the arrangement of these diodes. If plus is here, then current flows out through this one. This one does not conduct. It flows through the load, then back, then through this one, then into the negative terminal. Conventional current, which is assumed to flow from plus to minus. If plus is here, the opposite configuration, flows out through this diode. This one is reverse biased, so it does not conduct. Flows through the load, flows back up, flows in through this diode, back to the negative terminal. Only 2 of the diodes are conducting at any given time, depending on the polarity of the input. The net result is that, unlike in our previous experiment, the LED should light with either connection pattern with the battery. The diode serves the purpose of flipping the input voltage up the right way. Here is one orientation of the battery for input, and then if I reverse the polarity, oh hey, the LED still lights. Isn't that wonderful? So this property of diode bridges, which enables them to convert an alternating current, such as this one, into a pulsed positive current, such as this one, is the reason you will often see 4 diodes, or the 4 diodes integrated into a single part, like this, if you disassemble an old-style linear power supply How do you tell if it's old? Well, it'll be bigger and heavier on account of all of this laminated iron, which exists to give the magnetic field a path to travel through that it wants to travel through more than it wants to go through air or vacuum. I think that's about all for now. Till next time.